So for question number 3, we have a table that gives us several values of P of T, which is the number of passengers who have boarded a ship. For part A, we want to find the average rate at which the passengers board the ship. So average rate, remember average rate of change, we do know the formula for that one. And it's just this right here. It's like finding the slope of a line. You end up getting 99. If you just put 99, that's fine, but because they actually told you what the units were, they aren't making you put it, but you can also write passengers per hour. This part of the question is actually just worth 1 point, and if you get 99, you get that point. So for part B, we want to write P prime of 4.5 as the limit of a difference quotient. I'm going to give you that definition. If you don't remember it though, I do recommend you look back at your notes. So this is the limit definition of a derivative. This part right here is what we call the difference quotient. So in order to get the first point of this problem, you need to write out the derivative using the difference quotient. You also need to use 4.5 in there, and you need to use P in there. So I'm going to replace all my F's with P, and I'm actually going to replace all my X's with 4.5. So if you write this out, that actually is the first point that you can get for this problem. The second point is, believe it or not, it's not really related to the first part of the problem. They want you to approximate P prime of 4.5. So we know that 4.5 is halfway between 3 and 6. That's what they're actually going for on that one. So you are just going to approximate the derivative by finding the rate of change between 3 and 6, or finding the slope of the line between 3 and 6, which is going to be P of 6 minus P of 3 over 6 minus 3. Sorry, I should have written approximately equal to. When you evaluate that, you do get 132. And actually, they didn't ask you for units, but if you were asked, this one is passengers per hour. So I'm hoping that you recognize that this type of problem is, they always ask questions in this manner if they're looking for either the intermediate value theorem or the mean value theorem. In this case, we're going to be using the intermediate value theorem. So first point of this problem you get by mentioning that it's continuous. And if you look back at the explanation, I don't have it right here, but the explanation says that P is differentiable. So since P is differentiable, we know that it's continuous. So if we know that it's continuous, we know that we can use the intermediate value theorem. So I've written it out for you guys a few times. I recommend that maybe you just look back at your notes if you want to look it up again. I'm just going to kind of show you quickly how to do this one. So first of all, we use our endpoints. We know that P of 3 is equal to 205. We know that P of 6 is equal to 600. Since those two values are, since 500 is between those two values, we know that at some point the function needs to hit 500. So this is my answer for the question. I'll draw you a picture in just a second. So first point you get by mentioning continuity. The second point of the problem you get by using the intermediate value theorem. So I'm going to just explain in pictures why this works. So here I have an incomplete graph of P of T. I know what P of 3 are, P of 3 and P of 6 are. Basically, I know that the graph at some point is going to pass through 500. I don't know where, but I know that it's going to hit 500 at some point because of the intermediate value theorem. So the last part of this problem is basically just finding a derivative. So I'm just going to quickly show you how to do that. First thing I'm going to do with g of t is rewrite that square root of t as t to the 1/2. That's going to give me 120 times t to the 3/2. So I just use the power rule to do this. I end up getting 180 times the square root of t. If you get that, you get the point for this, the first point for this problem. The answer for this I get by plugging in 4. My answer is 360. You actually get full credit just for putting that, or you can put gallons per hour. But the last point is just for the 360.